FastMCP3 employs dynamic tool invocation through an asynchronous call tool function, enabling runtime composition of workflows by chaining tool calls in a sandboxed execution environment. This mechanism abstracts direct tool access, allowing scripts to discover and utilize tools via a standardized interface while maintaining isolation and control over execution. The upcoming code snippet will demonstrate how this dynamic invocation pattern is implemented, showing the sequential chaining of tool calls where each operation's output feeds into the next, culminating in a final result. You'll observe the asynchronous nature of these calls and how the sandboxed environment manages the workflow execution. A equals await call tool add, x, 3, y, 4. B equals await call tool multiply, x, a, y, 2. Return B. This code demonstrates dynamic tool composition using FastMCP3's call tool function in a sandboxed execution environment. The pattern shows how tools can be chained asynchronously, with each call's output feeding into the next operation. Here, add is called first with parameters x, 3, and y, 4, then multiply uses the result as input with y, 2. The await syntax indicates this runs in an async context, which is crucial for non-blocking tool execution in production systems. The approach enables flexible workflow composition without hard-coding tool sequences, making it ideal for scenarios where the execution path isn't known upfront. The trade-off is that each await introduces latency, so this pattern works best when tool dependencies are truly sequential. The sandbox environment ensures these dynamic calls remain isolated and secure, preventing unintended side effects from LLM-generated code. This is particularly valuable in CodeMode, where the LLM discovers and composes tools at runtime. Let's break it down line by line. A equals await call tool add, x, 3, y, 4. Calls the call tool function asynchronously with the tool name add and a dictionary containing parameters x and y set to 3 and 4 respectively, then assigns the returned result to variable The await keyword indicates this is an asynchronous operation that will pause execution until the tool call completes. B equals await call tool multiply, x, a, y, 2. Calls the multiply tool asynchronously with parameters x equals a and y equals 2, then awaits the result and assigns it to variable b. The operation pauses execution until the multiplication completes and returns the computed value. Return b. Returns the value of variable b from the current scope, exiting the function and passing b's value back to the caller. Dynamic tool composition in FastMCP3 hinges on asynchronous chaining through call tool, where each operation's output feeds into the next within a sandboxed environment. The pattern starts with await call tool add, pausing execution until the addition completes and storing the result in a. This value then flows into the subsequent multiply call, demonstrating how sequential dependencies are managed via await. The sandbox ensures isolation, critical for runtime tool discovery in CodeMode, while the async nature enables non-blocking execution despite the inherent latency of sequential await calls. The trade-off is clear. Flexibility in workflow composition comes at the cost of per-operation latency, making this ideal for truly dependent sequences rather than parallelizable tasks. The final return B delivers the composed result, showcasing how simple arithmetic operations can model more complex, dynamic workflows where the execution path isn't predetermined.
The function dreams of multiplying, but call tool wakes it with a sum.